Hi students, how are you? Today I am going to teach you a new lesson, that is matter around us. Okay, are you ready to learn? Very good. Relax and sit properly and relax, and always learn and just see the video and learn properly. Okay, always be relaxed. Okay, good. I will continue the lesson. Okay, first of all, after end of this session you will able to learn about the states of matter, shape and volume of solids, liquids and gases. You can tell about the properties of all the three states of matter, and also you can know about the compressibility of gases. Okay children, let us continue the lesson. Right. So first of all we will learn what is a matter. See, everything surround you. See, if you are sitting in a drawing room and seeing the laptop or the cell phone, every object around you is matter. Do you know? Okay, then what is do you mean by matter then? Anything that occupies space and has a mass in it is considered as matter. Understand? So that means when when you are sitting on a chair is a matter. Okay, when you are sitting on a plastic chair, it is a matter. Okay, and not only this, surround you the metals and non-metals that is present around you is a matter, and the synthetic fibers or natural materials, they are also matter. Okay, and the acids and bases which are used in the kitchen or in the laboratory or at your home, they are all the matter. Not only that, the water we drink is a matter, the air we breathe is a matter, and also the food we eat is also the matter, and the clothes we wear, they are also matter. Your spectacles, your shoes, all the objects, they are all considered to be as matter. Then what is matter? Which will it should occupy some space and has a mass. If it is occupy some space and a mass, then it is considered as matter. Okay, then not only this, everything in the world is considered to be as matter. Okay, that means water, if it is present in the form of an ice, is a matter. Water is liquid, is a matter, and the water vapor is also a matter. Only only difference is there may be change in the shape or size or texture, but they are all made up of matter. Okay, the clouds, water vapor, water, and the ice, different forms of water. Okay, and the wind you feel is a matter. The water we drink is a matter. The air we breathe is a matter. The food we eat is a matter. These everything, the clothes we wear is a matter. Okay, this matter is made up of? The matter is made up of small particles called molecules. If you observe the diagram, small particles are there. They are closely packed in solids, and they are moving freely in liquids and moving randomly in all directions is gases. Then these states of matter will have three states of matter, that is everybody knows it: solids, liquids and gases, and they can be changed from one state to another state. Suppose when you are taking the water and keep it in the defrost or in the refrigerator, it becomes an ice. That means you are changing the temperature. So when you are changing the conditions, solids can be converted into liquids, and liquids also can be converted into gases, isn't it? So these states of matter can be converted from one state to another state. So here if you observe this animation, the solids, the small particles, okay, normally the matter consists of small particles called molecules. What is it? Molecules. The small particles, they are, okay, they are the building blocks of the matter. Molecules and atoms are the building blocks of the matter. Matter, the basic particle is a molecule. These molecules are tightly packed and move slowly, okay, and in a fixed path, move slowly around a fixed path is solids. Liquids just regularly they are move, and gases randomly move in all directions because they will have a free space in between them. So matter exists in all the three states. You can convert from solids into liquids and gases, or three different states of matter. So for solids, ice is an example. For liquids, water is an example. For gases, water vapor. Okay. Now we will discuss about the solids first. Okay. So matter exist in all the three different states, isn't it? First of all, the solids. When you take the solids, if you observe the diagram there, all the molecules are regularly arranged. They are closely packed, regularly arranged. Will have a definite shape. That's the reason. Okay, so they will have a definite shape, size, and volume. You have learned in the lower classes, isn't it? The particles are closely and regularly and tightly packed. Okay, then they vibrates in a fixed position. See, if you observe the animation there, they vibrate in a fixed position. Okay, and they cannot move freely as in the case of gases or liquids. They cannot move. The particles or the molecules cannot move freely, and so that's the reason why they will have a more attraction between the particles will be maximum. Okay, if you observe the diagram there, the plasma is another state of matter, and Bose-Einstein condensate is another state of matter. Plasma normally present in the higher temperatures, that is on the sun, in the flames, okay, or in the stars. And Bose-Einstein condensate is in a generally at lower temperatures. If you are able to take the temperature to absolute zero, then this Bose-Einstein condensate will exist. Okay, these are the fourth state and the fifth state of matter. Now it is not necessary for you to learn. Just simply learn the solids, liquids, and gases. Now we'll go for the liquids. Okay, generally the liquids, if you observe the diagram there, if when you are filling the 500 ml of milk in a glass or in a beaker or in a conical flask, or 100 ml of milk in a glass, beaker, and conical flask, then if you observe there, there will be volume is same 500 ml only, but they are filled in a different shapes. So they are showing different shapes. That means they are filled in different containers. So it takes the shape of the container. So liquids have no definite shape but definite volume. The particles are not closely moves like solids. Okay, it occupies space but no definite volume. Okay, then what is this volume? Is a new word for you. The space can be termed as the volume. That space can be known as a volume. Okay, how much space it is occupying. Okay, milk has a fixed mass but no definite shape. Mass is fixed but no definite shape because it takes the shape of the container. Understand? So what is this? Which state of matter? Plasma. Good. And it is Bose-Einstein condensate. Very good. Now I'll go for the vapors or gas. Here if you observe that animation, the particles are freely moving in all directions and large gap between the particles or molecules. The molecules will have a large gap in between them, so they move randomly in all directions. So That means they have neither definite shape nor volume. The particles are far apart and move freely in all directions. Randomly they move in all directions. Okay. Good. Next, about phase. The phase is a new word for you, but it is similar to the state. The state of the matter. Okay, each state of the matter is known as phase. That's all. Okay, almost all both of them are similar words. Only you have to know is the each state of matter is considered or known as the phase. Then you have to remember that all the elements and compounds exist in three states, all the three states. That means iron can be a solid iron, a liquid iron, and a vapor iron. Okay, like that all the elements and compounds, water, solid, ice, liquid, water, and gas, water vapor, like that all the elements and compounds exist in all the three states. How it is possible? By changing the temperature and pressure. By changing the temperature and pressure, you can change the state of matter. Now we'll do an activity. Okay, identifying the shapes and volumes. Small activity. We'll take the water, oil, and the milk in different containers. Okay, let us take the containers: beaker, conical flask, and cylindrical jar. Okay, collect various containers. Take all those containers and take the water and add into the beaker, conical flask, and cylindrical jar. Okay, take the water and add into all the three. Okay, then what you have to do? You have to make a same amount. Actually, you have to draw the mark the level. Okay, and mark the level with a marker pen. Okay, because what you are doing, you are pouring the same amount of water in the each container. So you have to draw a level indicator. Okay, and observe those shapes. Then what you have to do? You have to repeat the same process for milk and oil also. So what we are doing now? You are taking the milk now. Okay, and adding into the beaker, conical flask, and cylindrical jar. Okay, after filling, you have to mark the levels with a marker pen. Okay, after marking them, again take a fresh beaker, conical flask, and cylinder and add oil in it. What you have to do? You are adding the oil into all the three and again mark them with a marker pen. Okay, so what we have taken? We have taken water, milk, and oil and marked all the levels. So what we will observe now is if you observe all the three, their volumes are same. Whether it is a water or a milk or an oil, their volumes remain same, but their shapes or levels changed according to this container. Okay, so that will be the observation. Then what you will observe? Liquids take different shapes based on the container, whereas volume is same. So what is your observation? It takes different shapes on the container, whereas the volume is same. And already I learned in the previous lesson what is a fluid friction. What are the fluids? Liquid flows easily from one container to another container and are called fluids. Liquids are called fluids, which can flow easily from one container to another container. Okay, so these are the properties and characteristics of the liquids. Okay, now we'll go for the activity for the gases. We'll observe the shapes and volumes of the gases. First of all, we'll take the CNG gas. Have you heard the name CNG? Yes, CNG, compressed natural gas. These gases nowadays are used in the automobiles. Okay, it is very less pollutant gas. Less pollutant gas. Okay, it is a colorless gas, and you can, okay, it is very useful also. So what is CNG? Compressed natural gas. So this gas is stored under pressure, because the name itself will tell you that compressed natural gas, so it is stored under pressure. Okay, these are the filling stations like your petrol bunks. These CNG filling stations are also available, where these vehicles will be filled with the CNG gas. So there will be a big tank present in the filling stations, and this gas will be filled into the vehicles, into the cylinders of the vehicles. So these gases will be stored into the cars or automobiles, into the, okay, then gas is filled in the filling stations into the automobiles like this, and CNG is stored in the cylinders in the automobiles at the time of driving. Okay, so these gases actually takes the shape of the container. It has no fixed volume and no fixed shape, because see, when you are trying to fill the air into the tube of a bicycles, well, how can you fill the air? With the help of a pump, air pump, isn't it? So there already the air is filled inside the tube, and you are trying to apply more air into the tube, isn't it? That means its volume is fixed there. Okay, so it changes its volume, gases. Okay, when you are applying the same air into the tube, you can fill more air into the tube, isn't it? That means it is having no definite shape and no definite volume. The gases will not have any definite shape and volume, so we call them as gases have neither fixed shape nor fixed volume. It takes the shape of the container. Okay, now we'll do another activity, that is compressibility of different materials. Compressibility of different materials. Take this a syringe. First of all, for this you need a syringe, 100 ml syringe. Okay, take the syringe and apply a force and drag the syringe backwards, so that it is filled with air. The syringe is filled with air. Okay, so draw the piston to backwards, so that it sucks the air. Now take the finger and stop, place at the nozzle and stop the flow of the air outside. Okay, put your thumb on the nozzle, then simply press the piston downwards. So when you are pressing the piston downwards, some of the air inside the the syringe will be compressed and its volume decreases. That means the depth of the piston moved inside. The depth will be reduced and it is moved inside the syringe. That means you can compress the gases. Air is a gas, isn't it? Like that, you have to take the water and also sand. So repeat the same for water and sand. Take the water inside the syringe and press it with your thumb, and take the this sand inside the syringe and try to press it with the thumb. So what you will observe is, first of all, you have to observe the depth of the syringe moved inside, whether there is any change or no change. For that, for gases, it can be compressed more. Okay, liquids very less, and solids you cannot compress the solids. Understand? That means what we will observe, the gases are highly compressible and when compared with the liquids and solids. Okay. So what you have learned in this session, you might have learned so many things, isn't it? First of all, you have learned different states of matter like the solids, liquids, gases, and other two states. What are they? They are the Bose-Einstein and plasma, isn't it? Like that, about the phase change, how can you change the phase by increasing or decreasing the temperature and pressure, and the properties of gases and the liquids, and also another important concept, that is compressibility of gases. You have learned, isn't it? Have you understood well? I think you have all understood well. And okay, very good. So whenever I ask, you have to answer very easily. Okay, remember the states of the matter. Okay, children, very good. Thank you.